In this question, it says a man's face is 25 centimeter. Man's face is 25 centimeter in front of a concave shaving mirror, producing erect image which is 1.5 times the size of the image. Well, we use concave mirror for as a shaving mirror because here the image form is really inverted. Sorry, when the image placed between F and P, the image formed is virtually erect, and it gives greater details of the face, and that's the reason. So if you write down the information that we have about this question is number one, we have the distance of the face. The face here, man's face is acting as an object, and its distance from the mirror is given as 25 centimeter. So this is the object distance, and object is placed in front of the mirror should always be taken as negative by the sign convention. And it forms an erect image. Erect is given, right? This image formed is erect, and it is 1.5 times the size of the image. Now we are going to take MS 1.5 because this is the magnification 1 times. And remember, magnification has no units, so we shouldn't write centimeter or meter. One more important thing, the M can be negative or positive depending upon whether it's a real inverted or virtual erect. So for an erect image, right, the M should be taken as positive. And had it been an inverted image, our M should have been negative in this case. Proceeding next to the part of the question, what they're saying that we have to find the focal length of the mirror. So F, as we know, this is a concave mirror. So we should get the focal length here. It should come as negative. Let's work out the calculation here. Now we cannot find F directly as V is missing here. So we can use the magnification to obtain the relation between V and U. So magnification M is equal to minus V upon U. It is true for all mirrors. Now M, which is 1.5, and V is not given here, U is minus 25. So we can reduce this sign and turn out V as 25 multiplied by 1.5. So that will give you the image distance, and image, as you know, in case of a shaving mirror, the image formed is virtual and erect, and it is on the right hand side of the mirror. So it's coming as 37.5. Now, this is centimeter, right? This is as the object is given in centimeters, object distance. Now, we'll apply this mirror formula finally to get the focal length of the mirror. So the relation is 1 upon F is equal to 1 upon V plus 1 upon U. So we have 1 upon F is equal to 1 upon V. V here is 1 upon 37.5 positive. Now I'm going to place the value of U here. U being negative minus 25, it will influence this sign. Plus minus is minus, so I'll write minus 1 upon 25. Further, to ease out the calculation, you can even remove this minus sign and write a 10 above. Remove this minus sign and write 10 here. And then you can even reduce it. Right? So if I reduce this further, what I get, reducing by 5, this is 2 times. And then we'll reduce 375 by 5. That should give you 75. Minus 1 upon 25. So 1 upon F comes out to be LCM as 75. This will be 2 times, and this is minus 3 times. Now with further cross multiplications, we can do this here. So F will, on reciprocating, it will come as minus 7. So once again, I can do a part of it here. It says we got 1 upon F as minus 1 upon 75. So by cross multiplication, we're getting F as minus 75. Now, as you can see, it's a concave mirror. You can see here, it's a concave mirror. And for concave mirror, its focal length is due to the left of the mirror. That should be taken as negative. Although in the options, when you get, we do not have as minus, because when we write in a statement, we don't use the sign. We can say 75 centimeter. So when you use symbols, make sure you are writing along with the sign. But when you use statement, you simply write the focal length as 75 centimeter.